So we've looked at parabolas quite a bit over the last year and a half or so. This year we've looked at graphing lots of parabolas along these lines. Parabola opens up. It's going to be a vertical stretch of y equals x squared by a factor of 2. Here I've got a vertical shrink by a factor of 1/6 and then reflecting x squared over the x-axis to give me negative 1/6 x squared. I can translate a basic parabola, y equals 2x squared parabola. I can then move it right 3 and up 7. If I switch x and y, I get a parabola that opens left to right. In this case, x equals y squared. I know I'm opening to the right. X equals 3y squared. That would be a horizontal stretch by a factor of 3 because I'm multiplying each x coordinate here by 3. I can take a parabola that's an opening left to right parabola and move it right 4 and down 7. So we've looked at parabolas. We've also looked at parabolas when they're not written in vertex form. If they're written in standard form and we've completed the square to find the vertex, or we've noted parabolas that open up and down, when we complete the square we get negative b over 2a, where a is the coefficient of the quadratic term and b is the coefficient of the linear term. Negative b over 2a gives us the x-coordinate of the vertex of that parabola that opens up or down. So now we're going to look at parabolas in a new way by geometric definition in this chapter. So to introduce us to this geometric definition, let's just first consider just a general case away from the coordinate plane. Suppose I have a line and a point not on the line, and I'm looking for all points in this plane that are equidistant from the point and the line. Well, one point clearly that's going to be equidistant from the point to the line is if I drop the perpendicular and I look at the midpoint of that perpendicular segment, that point's going to be equidistant from the point and the line. If I start looking, eyeballing here and finding other points that look to be about the same distance from the point to the line, that one looks like is 1. This one right here looks to be about the same distance as the point to the line. This one up here, let's see, about right there maybe. That distance kind of looks the same as this distance. Kind of. Close enough for our purposes. And I can do that, obviously I could do that on the other side as well. And so then when I go to connect all those points, I get my parabolic shape. So that's where basically that's our definition for a parabola, geometric definition. It's the set of all points, call this one xy, set of all points in a plane xy such the distance from the point to the point is the same as the point to the line. And note the distance from a point to a line is going to be the length of that perpendicular segment. So we're going to give a name to that point and the line. Our point is called the focus, and our line that we're equidistant from is called the directrix. So I can set up that midpoint that we looked at in that last diagram. If I set it up at the origin for the xy axis, set that midpoint up at the origin, and call the distance up to the focus to the point P and down to the directrix, call that P, I know then one point on my parabola is going to be 0, 0. So this is going to center, put the vertex of my parabola at 0, 0. If I put my focus equidistant from the x-axis, focus to x-axis equals directrix to x-axis, and I'm going to be looking at a case here where I'm going to get a parabola that's going to open up whose vertex is at 0, 0. So eyeballing a point that looks to be about the same distance, point to directrix, point to focus, those distances look about the same. Let's call the coordinates of that point xy. By definition then, this distance has to equal this distance. Let's label some other coordinates here. Label point coordinates here, since this is a perpendicular distance down, that x coordinate for this point is going to be the same as my general point here, xy, so I get a coordinate of x. And my y coordinate here is going to be negative p, because we'll let p be a positive value. We'll call this point up here, our focus then is going to be 0, comma p. So now I can go ahead and set up my distances. This is distance 1, and this is distance 2. By the distance formula, I want d1 equal to d2. By the distance formula, d1 is going to be the square root of x squared x minus 0 squared plus y minus p squared, square rooted. That's got to equal the distance of d2. Now d2 is simply a vertical segment, and that distance is going to be coming up to y and then going down p. That's simply going to be y plus p. And again, this distance here, if this length is p, and this length going up y, then my distance there is y plus p. So now if I go ahead and simplify this, I can then expand, or I can square both sides, so I get x squared plus y minus p squared, square root is gone, equals y plus p quantity squared. Now I know that this is going to be a parabola, looking at those points, eyeballing in those points. This is going to be a parabola that's going to open up, and its vertex is going to be at 0, 0. So when I go ahead and simplify this down here, I'm looking to get something in the form of y equals a number times x squared. All right, and remember, we've let p be a positive number, and so let's see what happens here when we go ahead and simplify this. So I get x squared plus y squared minus 2yp plus p squared equals y squared plus 2yp plus p squared. We get lots of stuff to cancel. The p squareds are gone, the y squareds are gone, and I get 4yp, if I move the negative 2p over to the right, equals x squared. I then can go ahead and solve that for y, and I get 1 over 4p x squared equals y. And that again is going to be a general formula for a parabola that's set up such that you have your focus at 0p and your directrix at y equals negative p, where p is a positive number. So let's take a look at a couple of examples and look at how we can go back and forth between focus and directrix and this coefficient in front of the quadratic term. Suppose I tell you that we have a parabola whose focus is at 0, 8 and whose vertex is at 0, 0. Well, let's think about this. We saw that the vertex is the midpoint in between the focus and the directrix. That's going to mean our directrix has to be down here at y equals negative 8. It means my parabola in this case is going to also open up. And at this point we should note that the focus for a parabola is contained within the parabolic bowl, and the directrix is outside of the parabolic bowl, focus inside the parabolic bowl, regardless of which way our parabola is going to open. And we then notice in this case, can we solve and find what p is? Well, it looks like in this case p is 8. So we know we have y equals 1 over 4p x squared, and we've got p equals 8. So therefore our equation for this parabola is going to be y equals 1 over 4 times 8 is 32 x squared, or y equals 1/32 x squared. Note our distance between, I've got a pretty big number here, length of 8. Let's take a look at what happens when that number is smaller. What's your intuition say about what that coefficient is going to do if I make this number p smaller? Okay, so let's suppose we have our directrix here at 1/32. So I've got a pretty tighter distance in here, and I've got my focus at 0, negative 1/32. Again, that'll mean my vertex here is at 0, 0. And eyeballing some points here, it looks like, for example, this point looks to be about maybe equidistant. I'm going to open, and we talked about before, we're going to open down. This parabola is going to open down. And if I were to pick some random point here, x, y, so that this distance equals this distance, label the coordinates, set yourself up, and you could do it by definition, find the equation by definition, or I note here, since I open down, this parabola is going to open down, it's going to be in the form of y equals negative 1 over 4p quantity x squared. I've set my p in this case equal to 1/32. So y equals negative 1 over 4 times 1/32 x squared. 1/32 times 4 is 1/8. Reciprocate. That means that you then have y equals negative 8x squared. So note, as p got smaller, my coefficient here, its absolute value got larger. And that makes sense because I'm looking at p as in the denominator here is a reciprocal relationship between the coefficient and what's down here in my denominator. So suppose you're asked to find the focus and directrix for something like y equals 3x squared. Y equals 3x squared opens up, so then I know I'm in the form of y equals 1 over 4px squared. That's going to mean that 1 over 4p here has to equal that 3. Solve that for p, so then I get p is 1/12. So I open up. If I open up, my focus is going to be here in the middle of the bowl, so the coordinates for my focus are 0, 1/12. My directrix is going to be below the y-axis, 1/12 of a unit down, so my directrix is y equals negative 1/12. So suppose you're asked to find the focus and directrix for something like y minus 8 equals 3 times x minus 4 squared. Note that this is going to be basically your y equals 3x squared moved right 4 because I replaced x with x minus 4, and 8 units up because I replaced y with y minus 8. So the strategy here is the same as with ellipses and hyperbolas. Look at y equals 3x squared, and then you're going to move the whole situation, everything, the whole parabola, the vertex, the focus, the directrix, move everything 4 units to the right and 8 units up. So we just saw in the last question for 3x squared, our p was going to be 1/12. So if I think about that, then I'm going to move the whole picture then 4 units to the right and 8 units up. Moving things up or down is not really, left or right is not going to affect my directrix at all. So I had my directrix before down here at y equals negative 1/12. So if I move that 8 units up, 8 units up from 1/12 will take me to 7 and 11/12. So y equals 7 and 11/12 would be where my directrix would go, for example. And I can move my focus the same way. My focus originally was 0, 1/12. I want to move that 4 units to the right and then 8 units up. So then I'm going to be at, my focus is going to be 4 units to the right. It's going to take me from 0 over to 4. And then I'm going 8 units up. That's going to take me to 8 and 1/12. So there's my focus and directrix, just viewing it as a translation.